Dark matter is completely invisible. It emits no light or energy and thus cannot be detected by conventional sensors and detectors. The key to its elusive nature must lie in its composition, scientists think. Visible matter, also called baryonic matter, consists of baryons, an overarching name for subatomic particles such as protons, neutrons and electrons. Scientists only speculate what dark matter is made of. It could be composed of baryons, but it could also be non-baryonic, that means consisting of different types of particles. Most scientists think that dark matter is composed of non-baryonic matter. The lead candidate, WIMPs, weakly interacting massive particles, are believed to have 10 to 100 times the mass of a proton, but their weak interactions with normal matter make them difficult to detect. Neutralinos, massive hypothetical particles heavier and slower than neutrinos, are the foremost candidate, though they have yet to be spotted. Sterile neutrinos are another candidate. Neutrinos are particles that don't make up regular matter. A river of neutrinos streams from the sun, but because they rarely interact with normal matter, they pass through Earth and its inhabitants. There are 3 known types of neutrinos. A fourth, the sterile neutrino, is proposed as a dark matter candidate. The sterile neutrino would only interact with regular matter through gravity. One of the outstanding questions is whether there is a pattern to the fractions that go into each neutrino species. Thijs de Jong, an associate professor of physics and astronomy at Michigan State University and a collaborator on the IceCube Neutrino Observatory in Antarctica, told Space.com. The smaller neutral axion and the uncharged photons, both theoretical particles, are also potential placeholders for dark matter. There is also such a thing as antimatter, which is not the same as dark matter. Antimatter consists of particles that are essentially the same as visible matter particles but with opposite electrical charges. These particles are called antiprotons and positrons, or antielectrons. When antiparticles meet particles, an explosion ensues that leads to the 2 types of matter cancelling each other out. Because we live in a universe made of matter, it is obvious that there is not that much antimatter around, otherwise there would be nothing left. Unlike dark matter, physicists can actually manufacture antimatter in their laboratories. But if we cannot see dark matter, how do we know it exists? The answer is gravity, the force exerted by objects made of matter that is proportional to their mass. Since the 1920s, astronomers have hypothesized that the universe must contain more matter than we can see because the gravitational forces that seem to be at play in the universe simply appear stronger than the visible matter alone would account for. Motions of the stars tell you how much matter there is, Peter van Dokkum, a researcher at Yale University, said in a statement, opens in new tab. They don't care what form the matter is, they just tell you that it's there. Astronomers examining spiral galaxies in the 1970s expected to see material in the center moving faster than at the outer edges. Instead, they found the stars in both locations traveled at the same velocity, indicating the galaxies contained more mass than could be seen. Studies of gas within elliptical galaxies also indicated a need for more mass than found in visible objects. Clusters of galaxies would fly apart if the only mass they contained was the mass visible to conventional astronomical measurements. Different galaxies seem to contain different amounts of dark matter. In 2016, a team led by Van Dokkum found a galaxy called Dragonfly 44, which seems to be composed almost entirely of dark matter. On the other hand, since 2018 astronomers have found several galaxies that seem to lack dark matter altogether. The force of gravity doesn't only affect the orbits of stars in galaxies but also the trajectory of light. Famous physicist Albert Einstein showed in the early 20th century that massive objects in the universe bend and distort light due to the force of their gravity. The phenomenon is called gravitational lensing. By studying how light is distorted by galaxy clusters, astronomers have been able to create a map of dark matter in the universe. A vast majority of the astronomical community today accepts that dark matter exists. Several astronomical measurements have corroborated the existence of dark matter, leading to a worldwide effort to observe directly dark matter particle interactions with ordinary matter in extremely sensitive detectors, which would confirm its existence and shed light on its properties, the Gran Sasso National Laboratory in Italy, LNGS, said in a statement, opens in new tab. However, these interactions are so feeble that they have escaped direct detection up to this point, forcing scientists to build detectors that are more and more sensitive. Thanks for watching.